Vanakkam. Welcome to this course on biomedical instrumentation. We have been looking at flow meters. In the previous set of videos, we looked at various types of flow meters. What are the various types of flow meters that we looked at? Let us recollect. Electromagnetic flow meters. Within this, we looked at two types of sine wave and square wave type. Then we looked at transit time. Transit time within ultrasonic, is it not? Ultrasonic Doppler, ultrasonic transit time, continuous wave Doppler, pulse Doppler, then laser Doppler. And in this video, we will look at thermal flow meters. So, what is the principle? A thermal flow meter essentially measures the flow rate, mass flow rate of a fluid or gas or liquid based on the heat transfer from a heated element or a cooled element to the flowing fluid. This is similar to Newton's law of cooling, wherein the heat loss depends on the fluid velocity. So, that means I heat up and how cool the fluid becomes at a known distance away from the heat source, for example, or how hot the fluid becomes at a known distance away from the heat source, I can estimate how much of the fluid has flown. If I can measure the heat at the source and heat at the destination, where the distance between the source and the destination I know, then by measuring the change of heat or the loss or gain of heat, I can identify the mass transfer that has happened, mass flow rate that has happened. So, a heater is placed in the flow path along with temperature sensors. What are temperature sensors? We looked at some of the temperature sensors in the previous set of videos, some temperature sensors. Thermistors in this case. As the fluid flows past the heater, it essentially carries some of the heat. More fluid passes in a given time, that means that more heat will be carried away. The rate of loss of heat is proportional to how much mass flow has happened. It is essentially proportional to the mass flow rate that has happened. So, you need to know the distance that the flow has gone through and the time that has elapsed, and you need to know the heat at the source and the heat at the destination where you are measuring, or the target that you are measuring. There are different types of these that are there. In one case, you maintain a constant temperature difference between the 2 points. How can you do that? Well, you essentially have a negative feedback loop. As more and more heat is carried away, you heat up the element more, and because I know how much heat is being carried away through the measure, the amount of heat that I am supplying is essentially a measure of the mass flow rate that has happened, and I control how much heat I am supplying, because more the current, more the heat, for example, simply put. So, one method essentially involves a constant temperature difference and measures the power required to keep the constant temperature difference, and that power required is proportional to the flow rate. The other uses constant power and measures the temperature difference. Now, in this case you supply for a constant power and you measure the difference in temperature between the 2 points, and this temperature difference is a measure of the mass flow rate. So, the heat transferred is essentially m dot, here it is kept m with a dot later, that is essentially a time rate of flow, okay, that is a dm by dt, m dot times the specific heat capacity Cp times, this is also not small Cp but Cp as per the equation, Cp is the specific heat capacity of the fluid times the temperature difference delta T. Right. So, the flow is, for example, happening in this direction, there is a temperature sensor here and a temperature sensor there, and there is a heating element, and I know this distance and I know this distance, right, and I have a sensing system. So, depending on how much flow is happening, because this is the heat source, I can actually measure the change in the heat. If I have two such sensors, two such thermistors, without knowing the direction, I can also know which is the direction of flow, is it not? That is another thing that I can expect. So, with this we come to the end of this video. In this video we looked at thermal flow meters. With this we end the topic on flow meters. In the next set of videos we will be looking at respiratory system and measurements of the respiratory system. With this we end this video. Thank you for your attention.